One of the hats I wear is the director of the Master of Engineering program in our Department of Civil and Environmental Engineering. And this is a one-year master's program that's designed for students who want to go into practice or return to practice following their master's degree. So there's very definitely a practical bent to that. But we try to affect the balance between research and practice. I encourage students to take some of the tougher classes that might be populated mainly by senior graduate students doing their PhD, and they may not get A's in all their classes, but I think it's a good experience for them. We also have a lot of quite applied classes that the students take. We have a lot of networking with local industry contacts and agency contacts through seminars, through job shadowing exercises. We do recruiting in our MEng facility, so we try to get students to rub shoulders with industry, and that helps industry find good people to work with and also students to find jobs. We are probably unique among programs of this sort, one-year master's programs, in that we require both a team project, which tends to be very applied in nature, and also a short individual thesis, which can be more basic. So again, we're trying to split the difference between those two. A lot of our students have really appreciated this experience, especially the opportunity to meet industry. Boston is a good place because there's a lot going on in the area, a lot of construction. Our program is tracks and transportation, geotech, structures, and environmental engineering, and all four of those sectors are quite active in Boston. So in general, students have been quite happy with the program, and it's been growing slowly for the last 15 years. Our goal through this program is to produce leaders in industry, and so some of our students don't stay in civil or environmental engineering, but many of them have, and they're rising through the ranks of their companies, becoming principals and owners in companies, and this is good feedback because they become examples for the current students. We bring them back and have them give seminars and tell us about their experience, and so the system feeds on itself. I used to be quite involved with our department's undergraduate program, and the aspect of that I concentrated on was the so-called senior capping subject. This is kind of the holy grail of engineering educators, in that it's supposed to provide an experience to seniors that integrates a lot of what they've learned over the previous 4 years in a practical, applied project. And it's difficult for faculty to do this because you've got to have interesting projects that are broad enough, and it's hard to sustain this. Well, when I was doing it, I had a model that I thought was effective. I leaned heavily on colleagues in the consulting field and also agencies, public agencies like EPA. And it turns out that a lot of consultants are closet academics. They're not much different from academics that do applied research. The big difference is in the outside world, deadlines tend to be stricter. So when somebody blows a whistle, you have to write up your work, you do the best job you can, you hope the client is happy with it and pays the bills, but then you go on and work on something else. The only problem is that intellectually the project may not quite be finished. So that's where we came in. We had a supply of 10 or 15 undergraduates who were eager to graduate and wanted to work on an interesting real-world problem. And so colleagues in industry and agencies were happy to share a little of their time in mentorship. It allowed them to be exposed to the students and get a good look at who might be a good employee. The students were happy to get this mentorship and work on an interesting problem. Sometimes we had to sign non-disclosure agreements, but there was no money exchange, so it basically worked well administratively and seemed to be a good model of. I think MIT is a great place to do interdisciplinary research. A wide variety of departments have overlapping interests, and there are also a number of centers. The MIT Energy Initiative, for example, has a lot of work going on that is supported by industry and is worked on by people from a variety of departments. I'm also involved with MIT Sea Grant, which in a different way does the same thing. It calls on people from a variety of departments to help fund research and participate. I can't think of a place that is any better than MIT at bringing people together to work on interdisciplinary research. We have departments, but people are not siloed in those departments. And so it's a very good opportunity to exchange information with colleagues.